Right, so this video is a quick example on finding prime factors. So we'll start with the question. We're going to find the product of the prime factors of 24. Okay. And it's the product of the prime factors we want. So we want a list of prime numbers that multiply together to get us 24. So there's two methods we're going to go through. The first one is the division method, where you just keep dividing by prime numbers until you've got all the factors of 24. And the other one is the prime factor tree method, where you just keep dividing by factors of 24 and picking out the prime numbers. So the division method is nice and simple. We just keep dividing by prime numbers. If we divide by 2 first, we get 12. If we divide by 2 again, we get 6. Divide by 2 again, we get 3. So we can't divide by 2 anymore, so the next prime number we can divide by is going to be 3. So when we get down to 1, we can't divide by any more. So those list of prime numbers on the left hand side there, 2, 2, 2 and 3 are our prime factors of 24. So we want it right as a product of the prime factors. So that's going to be 2 cubed, because we're doing 2 times 2 times 2, multiplied by 3. If you work that out, that's 8 times 3, which is 24. So the prime factor tree method is very similar. You just pick any two numbers and multiply together to get you 24. So a factor pair can be 8 and 3. So 3 is a prime number, so we just circle that for now. 8's not a prime number, so we just carry on. So 8 can be split into 2 times 4. 2 is a prime number, so we'll circle that. Carry on with the 4. That is 2 times 2. So look, as you can see, those numbers circled in yellow. And again, the prime factors are 24. Gives us the same answer, 2 to the power 3 multiplied by 3. So those, we can use prime factors to work out highest common factors and lowest common multiples of two numbers as well, which we look at next. Right, so for this question, we want to find the HCF, or highest common factor, and LCM, or lowest common multiple, of 24 and 30. We're going to use prime factors. We already know the prime factors of 24, which is 2 cubed times 3. So if we quickly find the prime factors of 30, so I'm going to use the prime factor tree method quickly. I've got 30 is equal to 2 times 3 times 5. Now what we're going to do is we're going to use a Venn diagram to display these prime factors. Alright, one circle is going to represent the prime factors of 24, and the other one is going to represent the prime factors of 30. And in the middle, we want to put any prime factors, like the 2 there, and the 3 in the intersection, so the bit in the middle. So actually we've got, both of them got a 2 and a 3 common, so we'll stick that in the middle. So this circle is going to represent the prime factors of 24. So I've already got a 2 and a 3 in there. So the numbers I've got left over is I'll have 2 2's. So if I stick 2 2's in the rest of the circle, okay, then that circle representing 24, look, I've got my prime factors, 2 times 2 times 2 times 3, and that 2 and the 3, which will be common for 30, is in the 30 circle as well. Okay, so 2 and 3 are already in there, so now I just need to put 5 on the other side. So a quick check of that circle, look, 2 times 3 times 5 is in the 30 circle. Okay, then it's a really neat little trick. To find my highest common factor, rather than writing out lists of factors and circling ones that are the same, I just multiply the two numbers that are in the intersection, so the overlap in the middle. Okay, so that's the symbol there for an intersection. So 2 multiplied by 3 is equal to 6, so that's my highest common factor, or HCF. My LCM, or lowest common multiple then, is I just multiply together all the numbers I see in my Venn diagram. So it's the union of the sets. So it's going to be 2 multiplied by 2, multiplied by 2, multiplied by 3, multiplied by 5, which gives me 120 is my lowest common multiple. So rather than write in all the multiples of 24, the multiples of 30, trying to find that, I can just use my Venn diagram. Small numbers like this, it's not any quicker than writing the lists, to be honest, but if you've got really awkward numbers, then it really speeds the process up for you. So it's a technique worth revising and remembering. Alright, thanks.